Okay, welcome back. So, we will continue with that exercise that we were looking at the light bulbs. So, earlier I kind of showed you those how we go from LCI inventory to the midpoint to the endpoint. So, now let's look at some of the results that we got based on, again this results is coming from a particular software, and I will introduce you to that software later in the class. We use a life cycle analysis software to come up with this particular graph. So, here as you can see those those abbreviation at the bottom that you see, those are our midpoint indicators, those those impact on different categories. If you remember, we looked at all these different categories: human toxicity, respiratory, ozone layer, photochemical, aquatic toxicity, terrestrial ecosystem. So, these are the different categories that I am using over, these are the categories over here. So, that are the different categories we have at the bottom. Those are, and then for fluorescence and incandescence, both are plotted at the same time. The first bar is for the fluorescent and the second one is for incandescent. So, usually what we do, the way we this is a standard way of actually producing these graphs, and this is how, if you look at any literature or any book on life cycle analysis, you will find that most of them actually report along this line. So, as you can see, that second of this column, they are all at 100%. So, what does that mean? So, they are all at 100%, they cannot be all at 100% for each and every category. So, what does that mean is this data has been normalized. The data has been normalized, where what they do is they take the category which is which comes out to be like the highest higher impact, the highest impact among the group. We make that particular data as 100%, and with respect to that 100%, we present the second data. So, here for incandescent, as you can see, for most of I think for all of them, we see that the incandescent has been shown at 100%. So, that means for each and every category, incandescent has actually better incandescent is like having a bigger impact. So, it's at 100%. So, based on that 100%, what is the impact of this fluorescent? So, that is what has been shown in the other column next to it. So, that is one thing. The other thing on this one is, you can see on the right hand side, this different nomenclature. We have different colors for different phase. So, we have purple for end of life, and we do see some purple here, purple like end of life impact. And then use phase is that blue, green. Green is the use phase, and the maroon or red, whatever you call it, is the distribution phase, and the blue one is the manufacturing phase. So, as you can see, for in fact all of them, other than your metal like a depletion, for all of them we see that it's that use phase has the biggest impact. So, the use phase is the use of the energy. So, that means it will have a lot of impact on what kind of energy is being used. Is it a coal based thermal power plant, or it is your hydro, nuclear. So, based on different types of energy sources, these will vary in terms of their impact. So, but that is the end of life, sorry that is the use part, that is the green one. Manufacturing, in some cases manufacturing has an impact, significant impact, as you can see, land use, change of land use, or in terms of the metals, we see a big impact on manufacturing. Then distribution has some impact as well. So, but here the most predominant one, the predominant the one is our the use phase. So, energy mix will have a big impact in terms of how this like light bulbs the results will show up. Same graph, just now here if you look at the bottom, here what we have done, we have taken the endpoint impact. So, it's a like a human health impact, ecosystem quality, climate change, and resource depletion, those four big endpoint categories. So, here again you can see incandescent bulb actually shows up to be much higher impact as opposed to the fluorescent bulb, and the different categories for end of life use, distribution, manufacturing has been shown here. So, for most part it is the use phase which is the dominating. So, again is the same thing. So this graph and the previous graph is the same information. Here the previous graph was individual impact categories, and in this graph we have taken the impact, those are the human health, ecosystem quality, climate change, and resource depletion. And these four, essentially these bars are summation of some of these bars from the previous slide. So this is summation of some of these bars is showing up over here based on which category comes what. So I hope I made that clear. So this again, it's the same data point as what we saw in the previous slide. So here again, if you want to kind of go into a little bit detail, and here things have not been plotted to 100%, so it is the raw data. So if you look at the previous two graphs, we had the things at 100% for the highest impact, but here they are not. So we have kind of a raw data. So this is non-normalized data that we got from different indicator results. So here again you can see the distribution in terms of the different types of categories, and this is just for kind of comparison purposes. That's what, and in terms of what is the like a real actually the actual values that shows up in terms of the impact. So here some data has been provided. So for example, PM 2.5 33%, NOx 22%, SOx is 20%. Electricity distribution, the copper is there, 43%, and then the generation coal is 18%. So those values are there as well. In terms of some of the impact here, we have the copper, chromium 6, electric distribution, like supply and distribution, and then we have this is the emissions coming out of that. Then we have some of these end of life. There is some uranium issues, so radioactive issues are there too, nuclear and thermal. So those are different categories that has been shown up over here. So that's in terms of this indicator result. So this is how you will get your results out from that software. So software does help you present some of these graphs. Some of these standard formats of graph, they may not be able to produce you the way you exactly want in terms of your research or thesis, but they do a decent job in terms of most of these softwares now has a graphing software already also part of that, and it helps you make the graph of the categories. So otherwise what you can get, which you will see in one of the examples later on in the semester, later on in this particular course, you can also get this raw data. So you can take the raw data and plot it the way you want to plot it, and then put it in a context that you want to put it in a context. So many companies do that, and they will not use these graphs. They will come up with their own graphs taking the raw data, and that's okay, but as long as they don't try to tweak the data the way they want their story to be told. So which is also happening a lot. So we need to be careful in terms of when you look at some of these sustainability results. So that was an example of an LCA. That was how the LCA is done. I hope it made it clear in terms of the different components that goes there. You need to, again, if you in a quick 1 minute, I will do a recap of what you did for this incandescent bulb and a CFL. First of all, you need to find out the goal and scope. You have to find, okay, what is the system boundary? Typical LCA is cradle to grave. So you did the system boundary, you come up with your functional unit. What is for both of them, the function is to provide the lighting. So we have to find out, okay, well, how much functional unit. So we take 700 lumens for 10,000 hours, and that was to give 10 bulbs of incandescent and 1 CFL. And then for 10 bulbs and 1 bulb, we did that LCI, life cycle inventory. We look at the impact categories. We look at the midpoint impact categories, and also the endpoint. And then we also looked at in terms of which phase it has the most impact, and we found that during its use phase is where we see the most of the impact. So those were and some of the graphs associated with that was presented. So that's kind of gives you an idea of how LCA exercise is done. And later on in the semester, later on in this particular course, I will again give you more like applied examples from some of the projects that we have done, or some of this stuff from the books as well. So in terms of the benefits and drawbacks of life cycle, so if we know now how to do life cycle, and we should have kind of got some idea by this time what are the benefits and what's the drawbacks, but let's look at them. What is the benefit and what is the drawback? Definition of LCA, it's an assessment method. So we are assessing something, life cycle assessment. So it is an assessment method, so it gives you some information. So it gives you some information. How good is that information depends on how good was all the ingredient that went into making this particular assessment, isn't it? So better data you have, better will be your results when you come up with the analysis. If you have a data set which is very poor, very sketchy, doesn't make sense, then there is a very good chance that when you do this LCA exercise, again this LCA exercise may not make some sense as well. So we have to be careful on that. So it's an assessment method. Assessment method means it gives some information. It's quantitative. So that's very, very important. It is a quantitative stuff. It's not qualitative. It's quantitative. Quantitative means that you need to you need to have numbers. That's what I was telling to you earlier. You need numbers because that's what we are interested in, especially the engineers. We want to have numbers, and the numbers are important here because we have to compare. We have to compare to different process or to different products or whatever. So in that, because most of the LCAs are in kind of comparison, those which are standalone is also used for comparisons later on. So that's we need to have a like a quantitative, like we can have the numbers there. Then it has to be comparative, with relative results, comparative to what is kind of expected. Environmental, all environmental effect aspect is considered. Product, service or corporation, we can do it even for system. And we have cradle to grave. That's the life cycle we are looking at. We are doing a cradle to grave LCA. So key features of LCA, it's a complete life cycle. So we do take care of all environmental aspects. So at least we try to. We try to take care of all environmental aspects in terms of when we do the life cycle analysis. So it becomes kind of it gives you the output in a much of a global perspective. So you get a more global perspective in terms of the output that you get out of that. It's complex. It's not an easy thing to do. It's a complex exercise. You need a transparency in the system to do it much better. Depth of detail of LCA will vary. That depends on the goal of the study. What is the goal? What is the standard? The guideline. Then there are some resource needs in terms of the time, money, software, tools, and they also vary. Sometimes your choices are unavoidable, although you may want to make every time like a correct choice, but choices are unavoidable sometimes, and there are no scientific basis to reduce your waste choices results to single score. So there is no scientific basis to reduce the choices. So basically there is a method, this recipe 2002 plus, or recipe 2009, impact 2002 plus. These are the different methods out there which one can use, but there is no hard and fast value choice how to go from this data to a single score. So that's really gets subjective sometimes. It may have also, there is you may see some of these LCA reports where things have been put where problem has been sifted. So when we say problem sifting, you have problem sifting in time where the recycled products, for example, if you are saying that okay, I will recycle most of my waste material coming out. Now this recycled product that you have has a lot of heavy metals. Now okay, you can recycle it once, you can recycle it twice, for example, then at some point of time you will have to stop recycling it, and then it will lose it will probably take much more energy and effort to recycle than to get a new material. So you may stop recycling it, and then that heavy metal will come into the disposal stream. So there will be cases of problem sifting where things are sifted, like we say recycle, and then things get sifted, although we may not count its environmental impact, but there is an environmental impact which may happen say 10 years down the line, not right now. And then there are in terms of problem sifting in terms of the space, where we can exporting the hazardous waste for like if you are doing a life cycle analysis on a hazardous waste related to stuff, and then you see that in Australia or US or maybe Canada, wherever from Canada you don't see that much of e-waste being exported, but there are several countries from where it does. So in terms of if it gets like you just don't want you don't want this hazardous waste. So but if it's hazardous waste is exported, it doesn't get calculated within the system boundary of the present problem, and then if you don't do that, you may see that certain things seems to be very good, but actually they are not, because we have just shifted the problem in a space, so to like for other area. So to like a problem is shift for other substances, like replacing zinc gutters by gutters in replacing zinc gutters by PVC gutters. So that's another could be PVC, polyvinyl chloride, we don't know. It may have some kind of health impact as well. We see that things are problematic in terms of those plastics. So those, again, we don't right now we don't consider the impact, but we may have an impact on associated with that. To the other environment contaminant compartments, if you incinerate waste that contains heavy metals instead of landfilling them, although it sounds really good that you are incinerating it, but incineration, you are concentrating the ash with heavy metals, because they will be present there, as most of the heavy metals, they are not volatile, and if they are volatile, they will become part of the air pollution control system. They are supposed they should be captured in the air pollution control system, and that should prevent them from getting into the atmosphere. So if it's captured over there, it will come out as a part of the flash. So things may just move from one environmental contaminant compartment to the other environmental compartment. That's why this LCA, which looks at the whole big picture and with everything together, is it's kind of a good tool to find out if we are making some mistake unknowingly today, which will haunt us, say 5 years down, 10 years down the line. So and it becomes another type of problem. For example, reducing acidifying emissions by increasing GHGs. So you can reduce the emissions coming out, and then there could be some other consumption, like spending saving from fuel efficient cars. So you buy a fuel efficient car and then you feel very good about it, but then you go on a holiday flight, so and kind of used up all those good fuel that you saved. Now you have to use it on the plane. But there is an argument, always an argument, that even if you don't go on plane, somebody will, and then plane will go on full, so it may not change much. But these are some of the examples of where we talk about this problem shifting exercise. So how this again why and how is again very important. So how this topic of life cycle assessment is started. Of course, the definition of sustainability started from the European Union. I already gave you the definition, I think 2 times. But how this concept of life cycle is started in terms of civil engineers or the environmental engineers, or say chemical engineers and other professionals who are interested in that. So here, usually what we have is what is known as the end of pipe approach. So we are not really we don't think much in terms of how the products are going to be made, because that's not my job as a environmental engineer or as a waste management engineer. So that's what we are focusing on is, okay, once the thing gets contaminated, we will go and clean it up. But that's not the focus right now. The focus right now has been, let's design things. Let's design things in a way so that it's easy to recycle. Let's design things in a way so that it's like a design for environment, design for sustainability, where things should be sustainable. And so that's how the role of our engineers are also changing, and we are becoming more and more involved in terms of this pollution prevention and all that. So this is how this environmental occupation has been growing in terms of evolution. What are the different assessment tools? LCA is one of them, but there are other tools out there, and some of them we have been using, some of them you must have been using as well as part of your some course, especially if you are a MTech students. So we had risk assessment, and then which is the installation and risk assessment is one course which is can be potentially used with this particular program, but that's another risk assessment is a very specific course. Its object analyzes the installation or substances. It could have local, regional, and also I would say even international sometimes. Aspects is ecotoxicity. So that's the risk assessment. Then we have this EIA, environmental impact assessment. EIA, as you know, as per the Government of India directive, for any new activity other than some which has been exempted, for any new activities EIA has to be done, and then EIA is done to find out what is the baseline condition. And first you find out the baseline condition, and then you try to model that if you put a new plant in there, what will be the impacts coming out of that. So that's your EIA, which is a local scale. Its aspect is variable. We look at the different aspects in EIA. Then we have substance flow analysis, which is again look at the substance. It could be regional or global. It may not be just a regional stuff. It could be a global scale too. And aspects, again, we are just looking at substance flow analysis. So there is no effect as such. Then there is LCA, which we talked about, which are talking about product and services, and then scale is global, and we look at the multiple effects. So these are some of the different environmental assessment tools that are used in terms of making some decision making. So LCA is a modeling of reality. Here you have a system definition, which you have your function and the product system. That's your economic model. And then you have your product inventory and the elementary flow inventory. That's the technological model. That's the inventory side. And then impact assessment is your impact category indicators, and the single score, that's the environmental model. And that's the impact assessment part of it. So this is we are trying to model. So whenever you try to model something, there is always, see, when we say we are modeling, we are already making some assumption, isn't it? Because the complexity of the natural environment cannot be replicated in any model. So you always take some sort of you already have to make some sort of assumptions anyway. So that's but at least you try to model as close to reality as possible. So that's another thing you should keep in mind. So function and product system, that's your economic model. Product inventory, elementary flow inventory, that's your secondary model. Impact category indicators leading to single score, that's the your environmental model. So that's the impact assessment model. So since it's a model, of course there would be limits to the model. There is an assessed impact and potential impact. Assessed impacts is that they are not real impact. They are exceeding thresholds, safety margins, or risk. So they are due to relative impact, like when we have a relative expression of impact score. So there is an assessed impact, and based on your you look at the functional unit, and then you do a relative expression of impact. So that's your in terms of limit to the model. Then how to integrate data of environmental data over space and time. That's again another challenges. And you can integrate the data over space and time. That's really a challenging stuff to do. These days with this big data and a lot of softwares and other stuff associated with that, things may get a little better. And then there are inherent uncertainty in modeling of impacts. When we are modeling the impact, there is an uncertainty. If you look at the IPCC document where this things first came in the United Nations, they also have when they try to suggesting some of these impact categories and all that, there is some uncertainty there as well. So it's when we are trying to model something, especially something which is very new, I think there will be iterations of model getting in fact better as we make progress. So there is an inherent uncertainty in modeling of impact. So we all talk about that. The fact that some impact categories clearly represents future impact. So we have some impact categories where we are actually worried more about future rather than right now. So only environmental aspect, that's another limit to the model. We are only focused on environmental aspect. Social and economic aspect is not considered in this particular one. Economic aspect typically is done what is known as LCCA, life cycle costing analysis. Social aspect we do it with social LCA, which is again also is getting popular now. Just recently social LCA guideline were formulated by CTEC and UNEP, which is CTEC is the Society of Environmental Toxicology and Chemistry, and it's a big organization, and they were kind of instrumental behind getting this life cycle analysis things off the ground at the global scale. So we are looking at only environmental aspect, no social, no economic, which are again also important. Inventory, we are not looking at all processes and flows because of we cannot really take care of all the process and flow. We do ignore certain things, the one which is less than 0.1% of impact, so we ignore them, and but a few of those can build up and have a decent impact level. So not all process and flows are considered, and many times the data quality is a problem to get data for each of these unit processes and flows. Then for impact assessment, it depends on your chosen impact categories. So there is some subjectivity that does get into, like if you choose certain type of impact categories, you may get a certain kind of, I would say, answer, and if you choose other set of impact categories, your answers may be different. So that's again, so you have to choosing of impact categories have an impact on what kind of like endpoint you will see. So available characterization model, how to, like, there is a we have to kind of look at some of these characterization models in more detail, and then having to have relevant elementary data. That's again, it's a big issue in terms of having a data. Again, data. That's always that's the number one thing in terms of a good LCA. Recently there was a meeting, and in India there has been in India this LCA is picking up now. There are people involved in LCA for quite some time. Every year there is a conference done on it is called Indian Life Cycle Management Conference, and it's organized by FICCI. So this year also it was organized by FICCI in October, and I was there. We had some presentations there as well. Again, there one session was just focused on how to get good data for doing better LCA. So you can think about, and once you do some research projects or even some consulting projects or industry projects related to this LCA exercise, you will find out that data quality is the major concern. So those of you who are doing lab experiments or pilot plant experiments, you should think about doing when you do your experimental design for your experiments, make sure that you collect the data in a way so that we can use those data for LCA exercise. So that's and then how to in terms of when you design your experiment, get feedback. If you are not sure, get feedback from somebody who knows LCA stuff, and by the end of this course you should know enough to make those decisions by yourself too. So with that, let's wrap up this model, and then we will see the other model where we start looking at some of the like benefits. Again, we will continue this benefits and drawbacks of this life cycle analysis model. Thank you, and I'll see you again in the next module.